All right, Mr. Dodd back again working through the limit definition of a derivative in order to get us through Calc 1. The first thing we have to start, again, this unit transitions us from the foundation, which is limits, this new idea that we hadn't dealt with, or at least most of us hadn't dealt with before we got to calculus, and then the idea of wanting to find the slope of a tangent line, and then being able to do that really, really well using mathematics. This is like the first start. So I can estimate the slope of a tangent line using a secant line. So I'm going to ask you about a specific x value. If you see down to my example here, I say x equals 5. The first step is you're going to pick an x value on either side of that desired value. You're going to plug those points into the original equation to find y values. You're going to use the x and y values to find slope. So slope formula we went in the background information we talked about. And then we're going to find the y value of the desired point by plugging in 5 in this case to the initial equation. And then you're going to use your slope that we found in step 3. And then your y value, x and y value, the point from step 4 in order to write an equation. And so fairly straightforward process, but I want to show you how to get there and how to accomplish it. So as I transition to my actual example, I really think it's important for students to be able to see what we're talking about graphically, and then what we are talking about algebraically, and be able to connect those two. So I'm going to start by just sketching this graph briefly. I can see that I have a vertical asymptote somewhere around 2. I wouldn't at least expect my students to be able to graph this function off the top of their head. Hopefully we can recognize there's a vertical asymptote because I have a value at the bottom that could be, if I plugged in 2, I'd divide by 0, so that's problematic. But overall, I only care about what's happening near x equals 5, so I'm not even going to worry about what's going on left of my vertical asymptote. So essentially, I have this guy right here, and it comes up and turns around, and then goes back up. So that's not a perfect rendition of what the graph looks like, and that's totally fine. I just want to give you guys a general idea. So the point that I actually care about is 5. So if I put a dot at 5, that's what I actually care about. And what we're going to do is go through and select a point on either side. So I'm actually going to use x equals 4 and then x equals 6. Okay, x equals 4 and x equals 6. And then if I draw a line through there, okay, do you see how that line would pretty much match up with the slope of the tangent line at that point? It's probably not perfect, but it's probably a pretty good estimation. Okay, so the way that I'm going to find my slope is I'm going to say m equals f of 6, that's just the y coordinate at 6, minus f of 4, that's the y coordinate at 4, divided by 6 minus 4. Okay, so as I plug those in, I would get 16 minus 8 divided by 6 minus 4 is 2. That's 8 divided by 2, which is equal to 4. So the estimated slope of my secant line, based on picking these 2 points and plugging them in, is 4. Okay, so then I want to find f of 5 so that I can write my equation